this video, I'm going to be reviewing some concepts from algebra that are going to be helpful as we progress through calculus. We're going to start by doing a very quick review of working with functions, looking at both notation and domain, and then we're going to just run through 4 different types of equations to solve. So let's start by considering the following function. F of x equals x squared minus 6x. I want to start by reminding you that notation, that f of x, stands for the output, which sometimes is referred to as the y value. So if we want to find f of negative 2, part A is asking us, what is the y value, what is the output, when x is negative 2? And so to do that, we're just going to plug the negative 2 in for the x's. So we replace all the x's in the function with negative 2. Negative 2 squared minus 6 times negative 2. Let's see, that would be 4 plus 12 or 16. So this is telling me when x is negative 2, when the input is negative 2, the y value, the output, is 16. Now we can evaluate functions with variable expressions as well. We can plug expressions into functions. So for example, if we want to find f of 4a, even though there's a variable a, we do this problem the same way we did part A. So we are going to take the 4a and we're going to plug it in for the x's. So again, whatever's inside the parentheses is the input, and we plug that in for the x's. So 4a squared minus 6 times 4a, we're going to square both that 4 and the a, so that's 16a squared minus 24a. We can't really do much else with that. That's our final answer. So one more, find f of x plus h, same concept. We're now going to replace both the x's with x plus h. So that gives me x plus h squared minus 6x plus h. We can expand this and see if there's any like terms. So to expand this first part here, the x plus h squared, we have to FOIL that out. You can think of that as x plus h times x plus h. And then your first is the x squared. Your outer is xh. Inner is xh. You add those together, you get the 2xh. Last is h squared. And then I distributed the negative 6. That gave me negative 6x minus 6h. There's no like terms, and so that expression is my final answer. So when we deal with functions, we're always going to be using function notation and describing various processes with this function notation. Now, I do also expect you to be able to find the domain of a function. That is definitely going to come to play when we're solving calculus problems. So the domain is the set of all inputs, or you can think of it as the set of all x values. Now, when you're finding domain, there really are 3 different things that you need to be thinking about. If the problem has a denominator, so if it's a fraction, if it's a rational expression, or anything that has a denominator, that denominator can't equal 0. We're not allowed to divide by 0. Division by 0 is undefined. If you have a square root or a fourth root, any type of even root, you can't have a negative inside an even root, so the thing inside the even root has to be bigger than or equal to 0. And then finally, if your problem has a logarithm, the thing inside a log has to be positive, has to be bigger than 0. So those are the 3 things we're going to kind of think about when we're trying to find domain. So I've got 4 different functions. Let's see if we can find the domain of each. And so let's just start with part A. F of x equals 3x over x squared minus x minus 2. This one is a fraction. It has a denominator. that denominator can't equal 0. We can't divide by 0. So I'm going to start by setting that denominator to 0 and trying to solve. This is a quadratic equation. I think we can factor this. Let's see, we're looking for two numbers with a product of -2, but a sum of -1. So 2 times 1 is 2, and if we make the 2 negative and the 1 positive, it adds up to -1. So we can factor this as x plus 1, x minus 2, and then I set each of the factors equal to 0. That gives me x equal -1 and x equal 2. And so in terms of domain, that's telling me x cannot equal -1 and x cannot equal 2. Those are numbers that give me 0 in the denominator. At the bottom of the screen now, I have this answer written in interval notation. So basically the domain is every single number from -infinity to +infinity, except not the -1 and not the 2. And so in interval notation, that would be everything from -infinity to -1. The middle part of the number line is -1 to 2. And the right side of the number line would be 2 to infinity. Notice I used parentheses. That's how we indicate that we are not including the -1 and the 2 as part of the domain. That's important. That's the idea here. The -1 and the 2 are not in that domain. Let's look at the second example. F of x equals square root of 6 minus 4x. We can only take the square root of positive numbers or 0, so the thing inside the square root, the 6 minus 4x, has to be bigger than or equal to 0. So minus the 6, divide both sides by -4, and because we're dividing by a negative number, that flips the direction of the inequality. In fact, anytime you multiply or divide an inequality by a negative, it changes direction. So now I've got x less than or equal to -6 divided by -4. We can write that as 3/2. And so in interval notation, my domain is everything from -infinity to 3/2. And notice I use that square bracket with the 3/2. That's because we want to include the 3/2. We have that less than or equal to symbol. Let's see, part C. F of x equals natural log of x plus 2. And the rule for natural logs is the thing inside the natural log, the x plus 2, has to be positive. We can't take logs of negative numbers or 0. So if x plus 2 is bigger than 0, minus the 2, x is bigger than -2. So that the domain in interval notation would be everything from -2 to infinity, and this time I use the parenthesis because we're not including that -2. All right, we've got one more. Let's find the domain of tangent of x. And I think the easiest way to do this is to remember that tangent is the same thing as sine of x divided by cosine of x. And so notice we have a fraction. Since we cannot divide by 0, that means cosine of x cannot equal 0. So let's think about our unit circle. Remember, cosine is the x-coordinate on the unit circle. So where does cosine or that x-coordinate equal 0? That would be those two dots I have drawn. That's pi over 2. So x cannot equal pi over 2. And then also, that would be 3 pi over 2. But notice that if you add pi, 180 degrees, that takes you to the next point, the one I have drawn in red. And in fact, we could add any number of pi's. We could add 180 degrees any number of times, and we'll always end up at one of those 2 points. So x cannot equal pi over 2, and we're going to say plus k pi, where k is any integer. That's a nice compact way of expressing the fact that any angle that's coterminal, or ends where those two dots are, is not going to be in the domain of this function. Now in this case, it's really hard to write this domain in interval notation because you have an infinite number of intervals. There's an infinite number of places where the function is undefined. And so I'm going to write it in what we call set builder notation. And so I have that written at the bottom of the screen. My domain would be the set of all x's such that x cannot equal pi over 2 plus k pi. All right, in the second part of this video, I want to review the idea of solving equations. And so I have a list of 4 equations. One has a polynomial, one is a trig function, a log, and an exponential. And let's see if we can review how do we solve these equations. So let's start with part A. And the first thing I try is to see if I can factor. So can we factor this polynomial? And let's see, well, we can definitely take an x out of all 3 terms. And so if I pull out an x, I'm left with 5x squared minus 13x minus 6. And so we're left with a quadratic. And so we have a couple of options here. We can continue to factor, or we could actually use the quadratic formula. I'm going to review the concept of factoring. And so there's a couple different ways to factor something like this. If you have a method that's different than mine, that's perfectly fine. I like to use the trial and error method. And that's where you just draw the 2 parentheses. You focus on the first term only, which is 5x squared. And you think about, well, how can we get a product of 5? And there really is only one option, 1 and 5. And so that tells me in the parentheses, the first thing has to be a 5x and a 1x. And then I move over and I look at the 6. I guess it's a negative 6, but I'll focus on the 6 for now. And I think about, well, how can I get a product of 6? There's 2 options. It could be 1 and 6 or 2 and 3. And then here's the trial and error part. I'm just going to try some numbers until my inner plus my outer terms add up to the negative 13x. So let's say I put the 1 and the 6 in. My inner is 1x, my outer is 30x. There's no way I can get a negative 13x out of that. So then I try something else. How about the 2 and the 3? My inner is 2x, my outer would be 15x. And let's see, well, if we make the 15 negative and the 2 positive, that will add up to the negative 13. So that means in the parentheses, the 3 has to be negative and the 2 is positive. And that's it. Those are my factors. Now that this problem is factored, I'm going to set each one to 0. So x equals 0, 5x plus 2 equals 0, x minus 3 equals 0. And so I've got 3 solutions. X is 0, x is negative 2/5, and x is positive 3. Now again, you could have used that quadratic formula instead if you prefer. The negative b plus or minus square root of b squared minus 4ac over 2a. That would be perfectly fine. Just make sure you don't forget about that x equals 0. When you factor the x out, you do have to set that to 0 as well. All right, part B, we've got a trig equation, sine of 3x plus 1. And so the first thing I would try here is see, can we get the trig function by itself? And we can, we just have to minus the 1. So sine of 3x equals negative 1. Once we have the trig function isolated, I'm going to think about my unit circle. Sine is the y-coordinate on the unit circle. So where is that y-coordinate equal to negative 1? Well, down there at the bottom, when you have an angle of 3 pi over 2, or we could call that negative pi over 2. Now, just as a side note, when we're working in calculus, when we do calculus problems, we're always going to work in radians. And so I do want you to get in the habit of giving your answers in radians, simply because calculus problems, the formulas that we're going to learn about really apply when we're talking about radians. So we're just always going to work in radians in calculus class. Okay, so the angle that gives me a sine of -1 would be 3 pi over 2. So that means the 3x, which is the angle, has to equal 3 pi over 2 plus anything that is coterminal with that angle. So that means I could add any multiple of 2 pi and end up at the same place. So we're going to say that our angle 3x has to equal 3 pi over 2 plus any multiple of 2 pi. So again, we could add 360 degrees or 2 pi any number of times and we still end up at that same point. So we're going to use that k to represent any integer and write that any multiple of 2 pi as 2k pi. Then finally, to solve for x, we have to divide everything by 3. So I divide everything by 3, and that gives me x equals pi over 2. So 3 pi over 2 divided by 3, I just canceled out the 3's. That gave me the pi over 2 plus 2k pi over 3, and that would be my final answer. All right, let's do 2 more. So natural log x minus 3 equals 2. So the first step is to try to isolate the log. And recall, a natural log just means you have log base e, where e is that natural number. It's 2.7 something, goes on forever. So the first step is to get the log by itself. We have that done. And then the opposite of a logarithm is an exponential. And the base of my natural log is e. And so to get rid of the natural log, you can think of it as you're going to take e to both sides. So e to the natural log of x minus 3 has to equal e squared. Again, e to a power and natural log are inverse functions. They undo each other. And so you can almost think of it as the e and the ln cancel out. They undo each other. And you're just left with x minus 3 equals e squared. Now, another way of thinking about this is you could just use the definition of a logarithm and rewrite the problem in exponential form. So what we have is a log base e of x minus 3 equals 2. Using that definition that I have circled in blue, this becomes e to the 2 equals x minus 3. That's the exact same thing I had written down in purple. All right, so now we've got x minus 3 equals e squared. We can solve that by just adding 3 to both sides. So x equals e squared plus 3. That's my exact answer. I could put that into a calculator and give an approximate answer of 10.389. All right, what about an exponential equation? We're just going to do the opposite. So we're going to isolate the exponential. That means add the 1 to both sides, divide by 2. And then we have two options. We can rewrite this in log form, or we could just take the log of both sides, and that's what I'm going to do. And I'm going to take natural log of both sides because this problem has an e in it. So I take natural log of both sides, and once again, natural log and e to a power, those are inverse operations. They undo each other. So when you take natural log of e to the 4x, you can almost think of it as the ln and the e cancel each other out, and you're just left with the 4x. So now we've got 4x equals ln of 1/2. Ln of 1/2 is a number. We can get it from our calculator. And so to solve for x, we have to just divide by 4. So my answer is natural log of 1/2 divided by 4. And we could put that into our calculator, and it becomes negative 0.1733. That's my last example in this video. I know that was a very fast review. Hopefully you've seen some of this stuff before, but please feel free to ask me questions if something is unclear.